day. Yeah, it's been a wonderful week so far. This is Friday. Today is Friday for people in Africa, or based on your time zone. But we are today is Friday here. Yeah, and Grace, thank you for joining. Thank you, volunteers on the call as well. Thank you for your work, tireless effort at the background. Thank you for all that you're doing. All right, so we'll just go right into what we have for today. Last class we touched on lists. We touched on lists, yeah. We touched on lists and we touched on subsetting lists. We touched on for loops, conditional statements, and lists. So today we'll be looking at dictionaries. All right, so we'll be looking at dictionaries today. We'll be starting off with dictionaries, tuples, sets, functions, and then, if possible, we'll touch on Streamlit. So that's what we have for today. So far, I believe we've been able to be following what we've been doing so far. And just like our normal agenda is, I'll be training for 30 minutes, then we'd have a 5 minutes quiz break. 30 minutes, I'll train another session for 30 minutes, 5 minutes quiz break, another 30 minutes, then would have a 20 minutes open forum. Okay, so we would get started right away. For persons that are having issues accessing the LMS, we'll take that to the end during the open forum so that we don't eat into a time for this session. I want us to cover as much as we can cover today so that we get into something else next week. All right. So we've been doing great so far. And I believe we've also been following the content on the LMS. Those are like additional resources that we could also, read through to enhance our learning. And for the sake of people that, have not joined before now, we have our recordings on the June 2nd. And there is a table here where the recordings are linked. So this is where we'll be having the links to the recording. So we'll be having additional column where we'd have the submission where we have to submit our assignment. So there are about 3 pending assignments that you all are supposed to submit. The Jupyter Notebook exercise, the Python crash course exercise 1 and 2. So I'll link up the assignments as well as the submission link where you can upload your submissions. Okay, so you just check here for the updates on this table. So today we'll be starting off with dictionaries. Where we talked about, we said expressions, variables, we've done some data types in Python, like the string, the integer, the floating point numbers, the booleans. Now we went ahead to do lists, and we did some list indexing and all of that. And now we are getting into dictionaries, tuples, sets. So these are their data structures in Python. And all of these data structures, they have their unique features. There's based on your needs, that's how you use them. And so dictionaries, I just want to show, I brought in this little tabular comparison so that, because this question is, it gets asked often in simple, maybe when you do some simple Python quiz, or maybe you're doing like any entrance job interview or like a beginner's job, and they would always want to test your knowledge of data structures. They want to know if you understand what the list is, tuple, dictionary, and sets. What are their differences? When are you to use them? When are you not to use them? And so this table is just going to give you like an overview of what these data structures look like. So if you have any question, please, you can ask your question, just keep it coming. At the end of during the open forum, we would address all your questions. Okay, so for lists, like we looked, like I explained earlier, we know that a list comes in a square bracket. If you want to define a list, you define it, the elements inside a square bracket. And you know that the elements are ordered. They are ordered in the sense that they have position. They are positional elements. They have position 0, 1, 2 to the end of the list. And then it's also, you can update the list. That is, it's changeable. You can update the list. And then it allows duplicate members. You can have more than one item that are the same in the list. However, for tuples are represented in tuples and lists. They are very, very similar. The only difference between tuples and lists is just that tuples they can't be changed. They are not. You can't update the elements in the tuple, unlike a list. I'll be showing you example as we proceed in this explanation, in this model. Tuple and list, they are very, very similar. The only difference is the square bracket. Tuple uses a normal bracket, and then they are not changeable. You cannot change, you cannot update the elements in a tuple. For dictionaries, which we'll also be looking at today, dictionaries are like your just think of it like your literal dictionary. You know, when you have a dictionary, you have some indexes, right? Where you just indices where you go to, you know, you want to look for a word, you go to, for example, you want to look for a word like structures. You first of all go to where you have the list of indices and check for structures. Then you go to the reference list in the dictionary to look for the definition. So that is how a dictionary also is defined. It uses a curly bracket, and it's unordered. You can't order it. You don't use zeros and ones to trace the elements in the dictionary. However, they can be changed. The elements can be updated. Just take note of this explanation when we are doing when I'm doing the practical explanation. You see that in practice what I'm saying. So they are changeable. That is, you can update the elements in the dictionary, and however, you cannot have duplicate members in a dictionary. You can't have two elements the same alike in a dictionary, unlike list. List allows duplicate, tuples allows duplicate, but then dictionaries do not allow duplicate. For sets, the unique thing about set is that set also does not allow duplicate members. You can only have unique values in a set. Note that list and tuples allows duplicate, but dictionaries and sets do not allow duplicates. And the sets cannot be changed. You cannot update the elements in the sets, and they are not ordered. That is, they don't have a particular order, and they use you can define the set using the curly bracket. So I just have that. I think, I don't know if I can update this notebook in the classroom so that you can have this particular notebook. The one there doesn't have this images. All right, so far we've seen how to store data types and sequences, like storing characters and strings. You know, when we talk about strings, we say strings are sequences of characters in quotes, whether single quotes or double quotes or triple quotes. Those are strings. Or we've also seen how to store list items. You can store different elements within a list, right? But what if you want to store an information another way, and you don't want to store it? Like, for example, you see that this is a list, right, where we have the new lists 1, 2, 3, 4, and 5. This is a beautiful list. You have the list function dot append. You can append elements in the list. But for dictionaries, there are times that you want an item to be associated with another item. That you cannot do within a list, and that's where you need a dictionary. For example, you want somebody's name and matric number to be in the same lists. You cannot store that kind of data in a list. The least you can do is to create a list for name. You can just say name. Felix. There's no Felix on this call. Sorry, I'm just using random names. Same and Paul. All right. Then you can also always say let me just say ID. ID is there are some reserved keywords. So when you see something like this highlighted, it's telling you that this is a reserved variable name. You cannot use it in Python, so you just have to change it so that you're not running into error when you want to use 01, 02, 02, 03. So now this is a list. If you want to store this type of record, you can only store it in two separate lists. You cannot store them together on a list in a list. But for a dictionary, you can actually store the name and the index together in a dictionary. And that's the beauty about dictionaries. It helps you to gives you a flexibility of you storing your name. I mean, your like two objects that are associated or related. It could be it could be an integer, whatever data type you can store within a dictionary. So in this case, you have Felix 01, Tame 02, and Paul 03. But for dictionary, how do you define a dictionary in this case? The first thing is the variable name. Any variable name you're giving your dictionary, you can say something like data, maybe data IDs. Or then you remember that dictionary, it's when you want to define a dictionary, it's enclosed in a curly brace. Then it has a key and the value pair. The key is the first, in this case now, our key would be what? The name of the person you want to store. That is Felix now, will be the, or you could just use the ID as the key, or what you want to use as the key. It could be your name or the name or the ID, but in this case, let's use the ID because that is actually unique. So you can say the key is 01 and then the value is what? Felix. Now take note of the definition of this first element. 01 Felix. That's how to define your key and your value pair in dictionary. That's the first item in your dictionary. The second item, the second item is 02. That's the key. 02. And then the value, same. And the third item is what? 03. And then the value Paul. All right. So in this case, it's easier to like reference people, users in this dictionary. There's okay, there is an error of a comma here. Oh, data. Now the name dates IDs is not defined. I made a mistake in the naming definition. So this is the dictionary we have of this item. So there's this flexibility of you referencing the elements in this dictionary, and that is that's part of the benefit of dictionary. So as you the choice of this deciding which sequence, like a list and mapping like a dictionary, often depends on the specific situation. So what that means is that depending on what you want, your use case, that's when you know whether you have to use a dictionary or you want to use a list. So let's cover some basics about dictionaries. All right, so like we have in lists, right? Let me load this new dictionary. Like we have in lists, we can also index a dictionary. And now that takes us back to our definitions. in dictionaries number one, they are curly brackets. They are unordered. That is, they don't have a particular. Sometimes when you have a very large dictionary, when you load it the first time, it will give you the particular order. But then when you load it the second time, the positions might change. So that's how a dictionary is. But then you can index the elements and you can change the elements. And that's what I want to show you now. I want first of all show you how to index elements within the dictionary. Okay, so we have this new dict, item 1, item 2, and item 3, Abuja. These are the 3 items. For example, if I want to get out the item 2, or item 2, yes, if I want to get out item 2, how do I get it out? Unlike list, it's the same thing like list. List is going to use the name of the list and then the position, right? But if you're using a dictionary, it's going to use the name of the dictionary, and then the key is the key. It uses the key to index out the elements. Now this element is going to use item 2, so it's very, very flexible. Item 2, you don't have to know the position. When all what you need to know is the key, and when you say item 2, it gets out the elements in the value of that dictionary. Now take note that a dictionary, right? The key can always be, the key can be the keys within the dictionary. Can be an integer, string, or any other data structure. However, the value can be a list. That is, you can have a dictionary with a single item, but then the value can either be a list, it can even be another dictionary within, and it could be another dictionary or a list. It can be an integer, string, a list, or another dictionary, but you cannot have a list as a key. So take note of that. The value can be lists, dictionaries, string, integer, etc. So just take note of that. So as we proceed, I'll show you other examples. Now, can you see indexing new dict item 2 is giving us 2. If we want to index new item 3, in this case, you'll see that item 3 is going to give us what? Abuja. So just take notes. It's still the same way of indexing, but then it's just you're not going to use the position to index. You're going to use the key, the name of the key, to index the elements. All right. Now let us look at updating elements in a dictionary. We said dictionaries are mutable. That is, they can change. They are mutable. They can change. They are changeable. So you can update. For example, I want to change the elements in item 3 to Kano, right? I can just call new dict item 3 equals Kano, and then automatically it changes it to Kano. Also, for example, I want to update the item 1 to something like maybe orange. All right, so I can just say new underscore dates. The key equals to what I want to update the dictionary to. Sorry, orange. When you load it, it won't show you anything, but let's print out the dictionary again to see the results of what we just updated. Now you can see that the item 1 has been updated to orange. So you can see that dictionaries are mutable. All right, let's move quickly because we have so much to cover. Now, what if you want to add new key item pairs to a dictionary? How do you go about that? Now, this is a dictionary, right? You want to update, you want to add a new key item pair to this dictionary. What I mean by key item pair, this new dict adds item 1, item 2, item 3. You want to add item 4. How do you add it? You use the same, okay, let me just go under this for the sake of um of clarity. So let me just print out that dictionary again. There's a dictionary called D. Okay. Now, this is the dictionary called D. I want to add a new key to this dictionary. So what I just need to do is to give the name of the key. That is the new key I want to add. You can use new key equals new item. And when you do that, it updates the value in the dictionary. So for clarity, let me use the one we've used before, right? Let's use the new dicts. Now you can see that this is our new dictionary, the one we have up there. So if, for example, I want to add item 4 here, I can just say new dicts, item 4, right? Okay, item 4 equals whatever I want to give the item. For example, I can say 45. So when you do this, you see that by the time I print out this, the output of this dictionary, have new underscore dates, and then you can see that item 4 has been added. So is that easy to do? Now, this is another example of a dictionary, of a list. I said that this dictionary item can be could be a string, it could be another list, or even another dictionary. So this is an example. For example, you have the BMI of some people, where you have the height as the key, and then this is a very good way to use a dictionary. You want to store the body mass index of some people. You have the height. Instead of you saying height 1 is equals to 23, height 2 is equals to 35, height 3 is equals to 36. You have the heights in as a key, and then you have a list where you have all the heights together. And then you have the weights, and then you have another list where you have the weights together. So easily you have the BMI, printed. Then if you want to include another update on that dictionary called total, you could just say BMI total equals 45, 60, 70, and then you have the results. So let me print out, and you want to include their state as well. So let me print out the BMI. Now you can see that this list, this dictionary has grown from this to all of this. So that's the way to store a dictionary. Like here now, you're having the key and then the values associated with the dictionary in a list. So that's about dictionaries. Now let us note that dictionaries are unordered. That is, you can have it's in a part. You can even have, it's not compulsory you have the name first or the grade or height. Sometimes when you do your printing, the height can come first, the grade. So how do you index out elements with the dictionary? Take note, you use the key to index it out, not the position, because they don't have any particular order. Okay. So dictionaries are very flexible in data types that they can hold. They can hold numbers. I mentioned that before, strings, lists, and even other dictionaries. So this is an example of a dictionary. So we have here D equals K1, that's the first key is 10, K2 is a string, K3 is a list. You can see that, right? K4 is another, this is a bigger dictionary in K4. That is how flexible a dictionary is. So when it comes to indexing, how do we index, all of these elements? Now, you remember that when you want to index a dictionary, right? You use the key to index a dictionary. But when you want to index a list, you use what? The position to index a list. So in this case, for example, what if I want to index out, I want to index out these lists. This is a list. I want to index out this list. How do I index it out? The first thing to do is you have to first of all identify where this list, where is it? What key does it belong to? What is the big, what's the outer key? The outer key is K4. So the first thing you do is to what? Let me load this to be sure that okay, I have the results. K4. So when you do DK4, you can see that you've indexed out the bigger dictionary. So now let's focus on this bigger dictionary. You know what we are trying to index out now? We want to index out, for example, we want to index out 30, right? You want to index out 30. That's the element you want to get out. Now, the next thing is 30 is inside a list, right? And the list belongs to this key. This is a dictionary. So you are going to continue from where you stopped, that DK4, another square bracket. What's the name of this key? That is, where is this 30 located? It belongs to this list, right? And the key is what? Inside key. Inside key. So when you do that, you can see that you're already getting there gradually. But now this is not a dictionary anymore. This is a what? A list. This is a list. You can see the square bracket. This is a list. So this time around, you're not going to use the key name. You're going to use the position to get out. Now we want to get out 30. So 30 is what position? Is our position what? 1. So let us just do 1. And that's how you get to your 30. So it's flexible. It's just like a build-up of what we've been doing over time. Can you still see my screen? Someone said my screen is not showing. Can you see my screen? I need somebody to, okay, thank you. All right, I think it's network, but then the recording is properly recorded. So let us just proceed. All right. So we have the indexing, in a very, you can do the same format of indexing. That's how you're going to index your dictionary. For example, when you use your retrieving elements in the dictionary, and then the key is not there. In this dictionary up there, there's nothing like ups. We just have K1, K2, K3, and all of the other keys. So if you use another key, it's going to tell you that you have a key error. And you can see key error. Oops, that's tell you that there is no key like that in a dictionary. Now, you also use dictionaries when you need to create a mapping, but you don't care about the number. For example, you can have a big dictionary of the states and capital in a particular country, or a big dictionary of this is the acronyms of some universities. So that's a way to use the dictionary. When you don't care about the order, all you just need to know is it's just to map the two dictionaries together. Another example is using like you can use it for population, the population of a country, maybe in millions. You can use a dictionary to store such items. Now, let us look at some methods associated with the dictionaries. We have dot values. That's the name of the dictionary, dot values. It gets out the values in that dictionary. Like in this case, our dictionary here is called short names. If you want to get out the values, you remember this is AAU is the key, and Booz Ali University is the value. So if you want to get out just the values of the dictionaries, you can just use short name dot values and it gets you out all the values in the dictionary. If you want to get out all the keys, you do short name dot keys, gets you out short name dot keys. If you want to get out all the items in the dictionary, that is all the elements in the dictionary, you can use short name dot items and it gets out the items within the dictionary. So we have say 5 more minutes to cover the rest of this. So quickly, I would explain what tuples are. Tuples are ordered sequences, just like lists. I mentioned that lists are ordered sequences, right, of elements, but then tuples are immutable. That's just the difference. That is, you cannot update the elements in the tuple. So let me show you what it means. This is a list, for example, right? If you want to change elements number 1 to another item, for example, I want to change it to NA. So you can just call my list, that is the name of the list. Then the position, number 1 is a position, what? 0 equals NA. That's how to update. Use the name, the index to update. You equate the index to what you want to update. That's how you update an element in a list. All right. So the same way you update elements in a dictionary as well. So when you do my list 0 NA, you can see that you have a new list with NA. You see, one has the position, one has changed to NA. But now, if you have a tuple is in a bracket, right? You have it enclosed in your normal brackets. But if you want to update an element, for example, I want to update the element in position 0 to 9. That is this 1. I want to change to 9. And I use T0 to 9. It's going to tell you that tuple object does not support item assignment. That is, you cannot change the elements in the tuple. So, and if you use your type function to check what the tuple, what is a tuple, you can see that it's telling you that it's a tuple. So just like a list, tuple can have mixed data types. They can be indexed. You can index them, but then the only difference is that they are they are immutable. You cannot change them. All right. So I haven't explained that. I'll just the same thing. I'll just re-emphasizing the explanation here. Okay, so we have some methods for tuples. You cannot update like when you want to add elements to a list, you can just say list.append. For example, you want to add an element to this list. You can just say my lists. Now you can see that you've added 4 to this list. But if you have a tuple now, this is a tuple here. And in this case, this is a tuple 1, 2, 3. Number 1, you cannot update the position. Number 2, if you want to add nope to the tuple, you find out that it's also showing an error, telling you that it has no attribute append. So that's just showing you the immutability feature of a tuple. For tuples, they have only 2 methods available called the index and the count. That is, you can get out the index. This is a tuple called ABC. Now, the beauty about this is a tuple you can have duplicates in a tuple, but if you want to have unique values, you can just call a set. A set changes, it helps you to streamline all your duplicates. So if you want to remove the A, maybe you have a very large data and you want the data with several duplicates. You can convert them into a tuple and then you call a set function. When you do set of T, you find out that all the elements have been removed all the duplicates have been removed. All right, so we have the count. You can count the elements. You can count how many A in this tuple. For example, you have like another A, right? And then you run t.count. It tells you the number of A. If you want to know the index, like if you want to find out the index of the A, it gives you the index, the first index in the tuple, right? So why do you use tuple? Like I said earlier, that lists and tuples are very, very similar. However, you can use tuple for collections or sequences that cannot be changed, that shouldn't be changed. Like when you have the date of the year or user information like the address, some things that you're storing in your database and then you shouldn't change them often, right? So you can use tuples for them. Another fundamental data structure is sets. The sets are an ordered collection of unique elements. Number 1, they don't have order. And number 2, they are unique. That is, they don't have duplicates. Just like we saw when we're converting that tuple with duplicates using a set. So you define a set using sets function. You can either use set function to define a set. So a set, beauty about sets is you can use it to perform some, so you can do x dot add to add an element to your set, right? It has some, unique methods like x dot add to add elements. Like you want to add one. This is an empty set, by the way. X is an empty set. So if you want to add elements, you can do add one, add two. It's going to add two to the elements. But take note that the curly brackets is not a dictionary. What makes it a dictionary is the words key and the value pair. So at this point, we are about few minutes beyond time. Let us go into the break. Okay, let me take this one. Now, this is a list of ones, twos, and three with duplicates, which is allowed, right? If you want to change it to a set, you just call the set function set my list. You can see that it's giving you all just the unique elements in the sets. So that is the way you can, use a set. If you have questions, please drop your questions in the chats. We would take them during your during the Q&A. So let us get into the quiz. Let's do a short quiz. If you can, please try as much as possible to participate in the quiz. It's going to help your knowledge of what we've been talking about so far. So we have this short quiz, and let me share the link so that you can all join. I just dropped the link in the chat. I just dropped the link in the chat. If you can join, please join quickly so that we can Okay, let me share the screen where we have the Slido. This is the Slido. That's 3 dictionaries. Waiting for as many persons to join. We have few persons. Please, let's all join. We'll start soon. Okay, so all right, we're going to start now. We have the first question here. Locks in 20 seconds. Square bracket is in an assignment statement will create which type of data structure? Square bracket. What data structure does it do? All right, we have all right, let us reveal the answer. I believe everyone should get this. It's a list. A list is enclosed in where? a square bracket. Well done. Okay, so let's go to the next question. Thank you, everyone. Which of these is the correct code for creating a list of names? Let's look closely. Correct code for creating, let's just use elimination method to do this. You might not look very correct code for creating. You have 4 seconds more. 3, 2, 1, 0. Thank you. I'm sure people that chose this number 4, the answer is the third the third option is the answer because of what? This is John. John has to be in what? In quotes. They are strings. They have to be in quotes. So that's why you have this as the answer. So let us go to the next one. Well done, everyone. List items have an index number in the following list. Which item has the index number 3? This should be very easy to get. Let's remember the 0 indexing. All right. Let's reveal the answer. The answer is journey. Remember, 0 is John, 1 is Ari, 2 is Jesse, and 3 is Journey. So this is index number 3. All right. Thank you, everybody. Okay, so let's go to the next question. 20 seconds. Are we ready? All right. Comparing a dictionary to Python, to a dictionary of words, dash is the word we look up, and dash is the definition of the word. Dash is the word we look up. 8 seconds more. Remember what I've been mentioning. I've been mentioning there's a particular word I keep mentioning in that order. All right. Thank you, everybody. You have the key and the value. That's the answer. Key is the word we look up. That is, and value is the definition. The key is like the index and value is the explanation. So it's always in a key and the value pair format. All right. Thank you, everybody. The next question we'll be looking at is in 20 seconds, let us answer this. Dictionaries use dash and keys are separated with dash. Dictionaries use dash. There's what do you use to define a dictionary and how do you separate the keys? 6 seconds more. 5, 4, 3, 2, 1. And then we have the results. Thank you, everyone. It's dictionaries use curly brackets, that is the bracket, and then the keys are separated with a full column. Remember, when we are defining your dictionary, you have it in a curly bracket and the keys are separated in a full column. I understand that the time is very short, right? And we are trying to quickly, scan through the answers, but it's just also a way to, get us to speed to help us. Let's quickly identify the right answer very quickly. All right. Thank you all so much for this time. Thank you, Bill, Abdullah, Muhammad, Toyi, Olayemi, everyone. Wow, we did very great today. I'm really impressed. We did so great. Thank you, everybody. All right, so let's get to the next thing on our agenda. Sorry if you're unable to join. The link was posted on the chat. We'll have one more before we close. I hope our time is, we're able to get to be fast where we are time. So quickly we'll be looking at functions. Functions. Function is something very gradually we are moving into, some structured coding. We've been doing building blocks, but structured coding. Now, let's take note that this course is Python for data science. This is not exhaustive of all of Python, right? But then it's going to give you all the necessary foundation you need when it comes to data sciences, even when you want to do just simple and basic Python we want to build a Python application. If we have time, we'll be able to build a Python application, and then we'll be able to share it on the web, like build a web app of just a simple web, maybe like a calculator. We'll build it using Python. But let's just ensure, I want to ensure that we cover the basics first, then we'll be able to we'll be able to touch on that. Okay, so I'm going to share my screen now. Okay, dictionaries. Okay, so let us functions. Now, we've been talking about data types, data structures. All of those things they are to form our basic understanding of how to define some of our data. I mean, when we are working with Python data sets. So let's take note that some of these things we're going to be using them when we get to when we want to do some data analytics. But next week, we'll be looking at NumPy, numerical Python packages, pandas for data analysis, data manipulation. We'll be doing that next week. So, but then having this basic understanding would really help to, during that time to help you to better understand those packages. Now, functions. Why do we have functions? We have functions, the one we've been, so if you're writing a code, you can just, what we've been writing is we've been writing just, basic declaring variable names, and then you're just writing dictionaries and all of that. But when, for example, you want to write a reusable code, something that somebody else can use, that is when function comes in. Most of this Python functions that are inbuilt were written by some persons that we just use them. And when we get to packages, you understand better what I mean, right? So a function is a block of organized reusable code that is used to perform a single related action. I won't go through all these stories. We'll read it, but I'll just give you the background of the use of function and how we can define our function. So, for example, normally when you want to calculate, you want to perform addition, right? You would have to, without using a function, you would have to say A is equals to 1, right? B is equals to 2 or 3. Then you can now say A plus B, right? So what is A plus B? Give you what? 4. So that's your function. I mean, that is just a basic way of calculating your sum. But instead of doing this, only you can have access to this. But if you create a function that can add two numbers together, anybody can always reuse your function. And that's what I'm going to explain very quickly. So in defining our function, you have this syntax when you want to define your function. The first thing is you have to use the def keyword. This is a keyword. When I say a keyword, is something that you can't change the word. It's a keyword in Python called def. Then this function name, you can give it any name. In this case, we can call our function name add or add to. In this case, you can say add to is the name of the function. Then in brackets, you have the parameters. These parameters I'm going to come to different way we use our parameters later in the code, but let me just give you a simple function so that's for the sake of people that are just, learning how to code. Your parameters are, in this case, we want to add two numbers, right? This is just a variable. You can call it something. You can call it num1. You can call it anything, number 1 or number 2, num2. So, but this is just telling the person that will be using this function that the name of this function is called add to, and then I want the function to have that anytime you're using the function, you supply me just two numbers. I don't want more than two numbers. If you supply 3 numbers, it will throw an error. So just supply me two numbers, and these are the variables here that you've defined here. Those are the parameters. Now you have the full column. Then this is a comment. This one is not compulsory, but sometimes you could just include it for the sake of people that read documentation, right? You could just put it that this function prints the sum of two numbers, num1 and num2. And num2. That's the function docstring and all of this. Now, the function, what do you want the function to do? All of these things, we're just defining this one is the def to tell, you're telling Python that, okay, I want to define a function using def keyword. Then you're giving the function a name, add to, and then you're giving you're telling the person that would be using the function that I want just two numbers, and that's why you're saying num1, num2. Now, you don't want to define the expression. What is the expression of an addition? That is what plus, right? So you're going to say here that num1, what this function will be doing is that it's going to add whatever number the person supplies, that's as num1, plus and any other number the person supplies, num2. So that is the expression you want it to execute. And then you cannot assign it. It's not compulsory, but you can just, for modularity, you can just assign it to another variable called C. And then you said you're telling the function to return C. Some people use print. You can just say you're telling the person to return C to the user. Now, this is just a simple way to define a function, and it's correct. So now if somebody wants to use this function, the person just needs to call the name of the function add to, and then the person has to, if I just call add to, it's going to give me an error, right? Because it's telling me that missing two required positional argument num1, and that's I have to supply two numbers. So I have to say add to 3, 4. That is the way it was defined. So if I write add to 3, 4, you can see that it's giving me 7. So every time I want to do an addition, right, I don't need to start adding the number. I can just always say add to maybe 1 million. This is just one. You can even put all the sorry, my keys are okay. You could just do something like this. This is a very complex thing for somebody to just quickly guess the answer, but then our function is giving you the answer already. So every time I want to perform addition, I don't have to stress myself. I just call this function. Any other person can use add to, and then they get the result as well. All right, so that's just a basic of a function. So this expression here can be anything. If you want to add, you can create another function. Let me see another example. This is another example. You want to create a function that is called excited. That is, anytime you call excited and you put you put a word in excited, it returns a print statement. Hello, I'm so happy learning Python. So this is another function. You can create your own function. If I say create a function that prints your name, right? If I just give you that task now, can you create a function that prints your name? If I want to do that, I'll just say the first thing I'll do def, and I can say my name. You can call it any, or you can just say print name or something. Print name. Now, in that print name, I want it to supply a word that is the name of whosoever will be using this function. So I can say name, right? Then full column. Then because I want it to print my name, I have to use a print statement. That's the expression that is defining that function, that is making that function different from every other function. So you're going to say print my name. My name is name. That's how to print a name, right? Or you can use your dot formats. anyhow you want to do your print statement based on what we've learned, you can either use the dot format or you can use this method of printing out your name. So, and you can now put your return statement, return. Now, not all function returns anything. Not all function returns a value. Some function don't return anything. So that is you're already getting into software development. Maybe you're building a robust application and you have to write several functions inside classes. So we won't be touching classes and some of all those things because this is not like a software engineering program. We are focusing on data science, and so we don't want to take us out of syllabus, but then I'll just show you the basics that would help you navigate, and you're comfortable doing your data science. And that's why I would really want us to get to Streamlit today, because Streamlit just he's the world of production, pushing. There are times that you, as a data science, you build ML models that can predict anything, maybe that can do weather forecast. But then all of your code is just inside the Jupyter notebook. How do you actually allow an external user to interact with it? And that's why Streamlit is very, very good. You don't have to know how to write HTML and CSS. You can just use your Streamlit application to, write some basic Python codes, and you're able to connect it to have a URL that people can interact with. All right, so I hope we'll be able to get there, but let's just see how fast we can go. All right, so this function now, by the time I want to use this function, I've defined the function. Now to use it, I have to use the name of the function, print underscore name. If I give it any name, if I say Grace now, it's going to give me my name is Grace. You can see that this I've defined a function that can print my name. I can give another name. I can say Felix. It says my name is Felix because I've defined that function. So I hope we get the background of defining functions. So this is a function that adds 3 numbers together. You can see here that because we want to add 3 numbers together, we want the user to supply 3 numbers, and that's why we're defining ABCs. And this is the operation you want that function to perform, and you're returning the answer to the person. So you've defined this function, and you can just say add 3 numbers. Whatever number you were putting in here gives you the result. All right, so you could have more complex functions. So these are just basics. All the while loop, the for loops we've been learning, everything can be inside a function. And the way you structure your Python codes, most times when you're building a more robust program or software, you have like modules for each of your codes, and functions kind of help you to organize your codes together. By the time you put them in for each of the module, like you have a module that is maybe, for example, you're building an ATM application, and then you're using Python. First of all, you have to define, you do like a user use case, you have to define different aspects of the system, you do a system design, you have to understand, okay, there'll be an input, there'll be some sort of underground backend work going there. There'll be a place for the database, different aspects of the system. So each of those aspects, now you write different functions or many functions. It could be 1, 2, 3, 4 functions for each of those aspects. You could have like, yesterday when we're looking at, the last class, we're looking at how to verify if someone's password is actually correct or not. You could just put that as a function. That could be user authentication function module, or you could use another function for verifying, checking accounts balance, another function for printing statements, another function, like that, so as to organize your codes. And then those functions, there's a way they interact together, you bring them together into a particular class. All right, so but we won't be going into that because as you're going down into software development and engineering. So let's just focus on what we have here. All right, so we have we've been talking about methods and functions, but what is the difference between a method and a function? Now, A method is also a function that belongs to another object. For example, like our type function, when you have a data type, like you're saying something like maybe A is equals to 56, and you want to know what type of data type is type A. It says the int. This is a function that someone has defined called type in Python, that you have to supply that any value you supply into type, it returns the data type. So somebody has actually coded this, and that's why you can use it anytime. Those are inbuilt functions for Python. We have some Python inbuilt functions like type and or some other function. But for method usually you apply it on an object. Like when you have a string, let me just use what is here so that I can follow. So we have most of the data types, they have their method. It's also a function, right? That someone has written, but then most times you apply it to a particular object in the use case you're different. Here, you see here that you're not, this one is not applied. You're using the function as the person has defined it, but here you're applying it to, this is a string, for example. You want to capitalize the string. This capitalize is a method that is associated with string. So anytime you call capitalize on a string object, it capitalizes the word for you or the string for you. There's another method called replace, that is, it replaces anything in that string. You're replacing R, we want to replace R with CT. So anywhere the C's are, it converts it to CT. And that's why you have prosper now has been replaced. You have peace, I can't pronounce it, but it's been replaced. All right. So we have other methods, like this is a list. Index, you can use .index to find the index of a particular element within this list. And here you have the country.index. So all these are just showing you what method, the way you use a method and the way you use a function. Okay, I hope that clarifies it. Now, having defined your function, I think we've done this, calling a function. The first thing you need to do when you're doing you have to define your function, which we've done here. So here, after defining, you have to call it. And you call it by what? Using the function name, and then what are the variables, I mean, the parameters that has been set for that function. That's how you call your function. So that's what I was trying to explain here. You have to specify, for example, the print sum that we have defined earlier. For you to print the sum, you have to supply 2 variables. So if I supply more than 2, it's going to throw an error. It's going to tell you that, okay, print sum is not defined. Let me reload print sum. I think it was here. We defined print sum somewhere here. Let me see if it's goes by. Okay, let me use the one that I can. Let me use add to now. Let me use add to in this case, because that one I can see it. 2. So add to takes just 2 arguments, but if you do this, it will tell you type error takes 2 positional argument, but 4 were given. So all of this, this tells you that, oh, okay, that means the person that defined this function is actually needs just 2 arguments, and then because I'm supplying 2, now I have the correct answer. Now I'm going to explain how to pass arguments to a function, of which I've explained earlier. But I just want to reinforce what I've explained. We haven't defined, this is a function that changes the name. It's a function that prints a particular name. That is, it's called change name. That is, it prints the name passed is the name that the user supplied. And then there is a name that has been defined. It's going to change the name into a defined name within that function to array. So that's what this function is doing. You're passing a particular name and it's telling you that the new name in this function is array. So what this is just showing you is that you can pass, there are several ways of passing arguments to a function. You can either define, you can say, for example, here, if you want to use this function, you just call change name, and then what I've been doing earlier, right? It's something like this. You having this, you just call the change name, right? And the name that you want to supply, it's telling you that you have to supply a name, right? You want to supply a name, you could just say Justin. And when you supply that name, it says the past name is Justin, the new name in this function is Ari. So you can either do this, or you can do like you can say A equals Justin. It's also a way to pass the argument. Sorry, got an unexpected keyword. Okay, sorry. You're gonna do this A equals Justin, then you're gonna call the name A. So you first of all, you can either define what you want to give the function, then you use that variable inside the function. It's still the same thing, but usually I just like passing the argument directly. There are just different ways of writing the function. Now, we have different type of function arguments. There was something I was trying to do earlier. I'm going to talk about the required keyword default and variable length arguments. And what I mean by arguments is that the parameters that have been passed, right? There are several ways you define them when you're defining your function. So normally that change name that we passed, that we initially defined, this change name up here, this is a function called change name, right? This is a required, the required argument says that change name has to have a value. If you don't give any value to change name, because here where the function was defined, it's telling you that it has to have a value, that is, it must be a name. It's not necessarily value, right? But then you must give it a particular name. Okay. I don't, sorry, somebody was saying something, zooming in. I didn't quite get that. Okay, is it that you can't see the screen very well? Is it very I need to understand. Is it that you can't see clearly? You can't see clearly? Is it clearer now? Okay. All right. Let us continue. Okay, so we have this function change name, right? The required argument says that there must be a value that you have to give change name. If you don't give change name any value, it's going to throw an error. And here you can see that because I didn't give change name a value, right? It's telling me an error that there's a missing positional argument value required. So what you have to do is you have to supply the name, right? And then you have the function working. We also have the keyword argument. So what the keyword argument does is that instead of you calling the function like directly, you could use the keyword that's been given in the function. Now here, the keyword given here is value. So you could just set change name value equals this, and then it returns the answer to you. You will do this most times when you are doing like when we start looking at some of our libraries, and but you see how we're going to we'll be using all of this function. By the time you start doing pandas, you start doing numpy, and you start doing some of this packages, start using some of these packages in Python, you see that when you are using Seaborn, you see that you'll be using some of these keyword argument functions very well. All right, but just take note that you can use the value defined in that function to supply your value in the function. That is still the same thing. You can either call it like this or this way. So that, but that's the keyword argument. Now you could also have the default argument. So where the default argument comes into play is that there are times that some functions by default, they've supplied a particular value so that even if the person does not supply anything, the default overrules it. So in this case, when you have a function that prints in print info function, right? And then what the function is doing, it prints the info about the person. What want to print the age of that person. So if the person forgets to supply anything, the person just calls the function name alone, it's still going to print something because by default you've set the age to be 25. I hope we are following this. Like if I load it, but if I now want to change, like if I want to now give it my own value, I can say 67 print info, and then you can see it overrides the default. So if you don't supply a value to the function or an argument to the function, it takes on the default argument. So that's another way to declare a function. You can declare it within using a default argument. For example, you want the function to always have a value in place. So you can put a default argument in that case. You can use a default argument. Then we have the variable length argument. Now the variable length argument is very interesting because you can take more than one argument. You know, that the other time I was trying to use a function and I supplied more than one argument to the function. Sorry, I supplied more than, okay, this is a variable length. So this is the syntax for the variable length argument. You have the def function name, then you have the name of the arguments. I mean the arguments, and then the variable argument is always in star. That is, you're saying that that argument can be more than one. That's what you're telling that function. So I don't want you to be confused with all this syntax, but what you should just focus on is just very simple, right? It's as simple as what we've been doing before. Let me just use another one so that you can get it clearly. For example, want to say def sum. If I use sum is it's a variable name in Python, so I can't use the sum. So it's telling me I can't use sum. So let me use another one, summing, right? And then I say something like a e. Now I want to add more than one number together. I want, even if the person supplies more than more than two numbers, I want it to still perform that addition. So I can just do something like this. A plus, I believe. Okay, let's do return C. Right, let's see what this gives us. I mean, so there's an error somewhere. Oh, well defined. Oh, int. Okay. Int. So this is going to be an issue. This is going to be an issue. Let me use another word. Let me use another word so that it will be easier to manipulate. A performing. think I didn't use this. Okay, still the same things. Okay. Okay, so what happened here is that here I can pass in more than one argument when I use star. It can take more than one argument. That is, if you want to pass in more than one argument into your function, and it, I had to print it so that you'll be able to see what the argument looks like. So here, the first argument I supplied was 1. So for the second argument, when I passed more than one, converted it into a tuple, right? And then you can see the arguments printed here. The other numbers are 2, 2. If I had more numbers, even though the function is defining just A and B, but then I can supply more than one number and then it takes the number as a tuple. So you use that majorly maybe when you want to perform a particular operation that requires tuple, and then you don't want the user to, maybe the user can either define just 2 items. If the person just writes 1 and 2, this is what the results would look like. So but if you have more than one or 2 items, you can still use such items, such elements within your code. So that's what the variable length argument does for you. It's an asterisk is placed before the variable name that holds the value of all non-keyword variables. The tuple remains empty if no additional arguments are specified during the function call. So that's what the variable length argument does. So in this case here, this is a print argument of name and the scores of the particular person. Yeah, this is a good use case. Now, the name that's the format name. And then if you want to print the scores as well, you can print the scores too. So when you print John, 80, 50, it's going to print the name and then the person's scores associated with the name, with that name. So that's how you use a variable length argument. Now we'll be looking at the return statement, which you've been using over time. Most times you find out that the return statement is the final statement you use when you're writing a function. All right, and then what the return statement does is that it gives an output to the user for that function. You're going to see a particular output in that function. So that's what the return statement does. So you can, most times, some people use print as well, but it's not all the time you can use return. There are some cases whereby you don't want your function to return anything. You just want the function to perform a particular operation. You might not have to include your return statements. A return statement with no arguments is the same as return none. That is, you're not returning anything out of that function. Now, finally, I'll talk about global. Second to the last thing I'll talk about is global and local variables before I talk about packages. Let us take note that when defining our function, most times when you're writing a very, very big program, you would come in contact with variable naming issues. And you have to be careful when you're doing your variable names because you might have errors. Well, if you don't properly name your variables. Now, the variable names, we have the global variable. Global variable is global, just like the name the name implies. It's global to the entire program. That is that name. This, like for example, this is let's take this as a program, right? In this program, you can have many functions within a program. You could have example, you could have another function, but here you have a variable that's been defined outside this function called number equals 20. And you have another variable here that has been defined inside this function. So this one outside here is a global variable. This one inside here is a local variable. That is, it is local to this particular function. However, the one outside here is global. That is, any other function outside this is outside your function. Any other function or any other code outside this particular function can use that, can access that variable. And that's what this is doing. Now, this is a number called 20. You're defining another function called example, where you set the number that any user supply, you set it to this number, and then it's printing that this number is local to example. But this one outside 20 is global to the entire program. I don't know if you get the explanation. So when you're defining your function or you're doing your function naming, you have to be sure that, okay, when you're naming your function, you have to be sure of what you're actually using to name your function, so that there won't be like a conflict or misunderstanding when you're having your output, the code output. So in this case, this one can only be accessed within this function, but this one can be used outside the function. So here, when you print this function, you can see that 20 is actually global. So that's why you are having it used here, even though you know that this function has been executed. It's global. That's why you're still seeing that function being used there. But then this 70 was supplied by a user, and then when it gets here, the number is 70 and it prints the local example. I mean, 70 is local to example, and you have this as a local variable. I hope this is clear. All right, let me give another example. Now, this is a variable called sum, which is equal to 0. Now, you want to add two numbers together, right? And you've said that the addition is what? A plus B. And when you print out the number, it should return the sum. Now, this function should what? Perform this particular, should perform this particular operation, add num 10 plus 20, right? And it should give you what? 30. So the answer from this function should give you 30. But because this is a local variable, this is a global variable, right? This sum is going to be printed outside here. And you have the sum has 0. Right? Normally, Python executes top down. If you're executing a particular line of code, this one executes first. Afterwards, you have this one executes. Then afterwards, you have this one executes. So when it takes the first variable in memory, sum is equal to 0. And then it comes into this function, sum, add num, and all of that. Sum is equal to, it is not referencing this sum. It's because this one is unique to this particular function here. And this sum is just within this place. And that's why you have this variable as a local variable and this as a global variable. So I hope that helps to clarify what a local variable and a global variable is. All right. I know we are getting so much. There are a lot of things you have to take in at once, but I believe that as you work with more examples, you see that it will be easy to assimilate. You begin to understand some of the things that are being taught. All right, so that's just a bit about function. I'm going to touch on packages quickly and see how we can. We have 15 more minutes. I don't know if you can quickly deploy a Streamlit application, depending on how fast the whole installation process look like. But let's see how we can do that. Okay. So we've been doing functions, we've done data structures, we talked about functions, and now packages. Functions and methods, like we're talking about, they are very, very powerful, and but if you have all your codes in one Python distribution, like when you're building an application, for example, you can have separate Python files. I'll show you in Streamlit when we start doing that. You can have separate Python files, performing different functions. But most times for people that are beginning, they're just beginners, they just write all the codes in one place. You just have everything in one place. You have different functions in a single place. And that could be very messy. your code wouldn't be organized, and you can even get some things missing when you do that. So that's where package comes into play, where you can have a package. Just think of package as a directory of Python scripts where you have different Python scripts, and each script is called a module. When we start pandas is like it's a Python package in Python, the package in Python, pandas, numpy, they are all packages, because within packages you have smaller modules, and those modules are like separate functions. Like within the numpy is numerical Python. It helps you to perform numerical analysis, very, very, intelligent numerical analysis. I cannot use lists and dictionaries to do. NumPy can do that. Pandas is a very good package for data manipulation. You want to manipulate data that has to do with Excel, CSV files, HTML files, so many files. Pandas is very, very good at that. It can do a lot of data manipulation for you. It works like SQL. Similar to, it can do some, so many sorting and so many very, very intelligent things. So there are so many modules, like functions, that have been inbuilt inside the pandas package that you can use as well. So if the people that wrote pandas on numpy package, and they have to combine everything together, we won't be able to use them now today. And that's why when you're writing your codes, it's also good to like have them in a package format. That is, you're having a directory. It's just like you're having a folder in your system, and you have many files, and each of those files are like different Python scripts, Python modules. So the entire folder is just the package, and then you have the different files in the folder as your modules. You can have one module that is performing the sum, another module that is performing an array operation, and all of that. And those modules, you have several functions in there. So it's like that. And then they also specify methods, and they solve a particular problem. So Python has tons of packages, and some of the example of data science packages I've mentioned it earlier. NumPy, pandas for data manipulation, scikit-learn for machine learning. You have the Keras package to use it for deep learning. You have so many packages in Python. You have TensorFlow, you have PyTorch. All of those packages, they are great packages. Streamlit is also one of the Python packages. So most of these packages, you find out that people that go the research way, like if you are more research oriented and you want to help us, the people that use some of these codes, you can decide to go and create your own Python package. So like somebody created Python package, somebody sat down to think around, okay, how can I make the life of data scientists or machine learning engineers easier? Let me create an HTML, CSS kind of package that are written in Python, that people can easily use. You can just use that package and you create a website. You don't need to know HTML and CSS. When you're using some complex packages, you don't need to know you don't need to know the mathematics behind how they work. You just have to know what is used for, right? And then you just use the package. So I don't need to know the nitty-gritties of all the CSS and the HTMLs. I just follow the way it's used, implemented, and then I'm able to like implement the package. So if you want to use a package in Python, the global and the local variable, let me try to cover what we have. If we have some more time, I'll take that during the open forum again. All right, so let's just try to cover the bits that we have so that we'll be able to be on track with our learning. Okay, so for you to use like for example, when we want to use NumPy or pandas, well, I'll be explaining that next week. The first thing is to install pip. Normally when you have your Jupyter Notebook and Anaconda installed, pip is already installed for you automatically. But if it's not installed on your system, you can download it at this website, and then you can run on Windows. You can do py get-pip.py, or on Linux or Mac, you can use Python get-p.py, and it installs pip. Pip is a package maintenance system manager for installation of any Python package. So usually when you want to install any package, you use your pip install, the name of the package, which you'll be seeing how I'm going to install the Streamlit package soon. And then after installing that package, first you have to install the package. After installing it, that's when you can now use that package. For example, NumPy is a numerical Python package. You can use it to perform numerical analysis like addition, subtraction. You can use it to perform linearly. You can use it to perform so many functions like linspace, normal distribution, and so many other functions that you want to do in mathematics. You can use it for matrices and so many functions. I don't want to start, touching on that now, but I just want to give you an example on how to use the package. NumPy is a package. You can either import it fully. There's a module in NumPy called array. Normally, if you want to create an array, you would have written so many Python codes, but then there's a module already provided in NumPy called array that you can easily convert a list into an array. I'll be explaining that when we get to NumPy. Right? So you can just say import NumPy, and then normally if you just do array 1, 2, 3, it's supposed to throw an error. Because I've run this model before now, that's why it's not showing an error again. Normally, if you use array 1, 2, 3, it should throw an error without we should show you and should throw an error that array is not being imported. So you have to reference the module that is numpy.array before you can use this module called array, because array is inside NumPy. Sorry. Array is inside NumPy. You just say numpy.array and then you are able to use the array. So there's another way to import array. We can also import the function only. Instead of importing the full package, you can just import the function you need. And that's where you do from NumPy import array. And then that's where you can easily use the array itself. So that's the way you can use your packages in Python. I hope we understand this. This explanation, I'm going to take it again when we get to NumPy and pandas. So don't worry if you can't understand it. But then it's very, very straightforward. When you want to use a package, you first of all install it. After installing it, that's when you now use it. You can either import it import the full package like this, or you import just the module that you want to use. Like NumPy is a module inside array and you put the module. All right, so that brings us the end of functions. We have few more minutes. Let's quickly take a short quiz before we continue, and then we'll take one day at a time. Okay, well done. Don't be overwhelmed by this. It's going to, it can only get better. You would get to understand as as you progress in your learning. All right, but let's just take this short quiz before we go into Streamlit. I'll just do a short demo. We might not really go into the technicalities, but I just want to do a short demo of how to take some of what we've been doing, how to publish it on the online, how to use it online. So at the end, we'll be doing a project at the end of this course, and we'll be using Streamlit to implement our project. So in the classroom, there are some videos linked there. You can go through some of those content. They're very, very good content, and that's why we linked them there. Yeah, so we have a video for Streamlit. Okay, so two people sent us their application. They already built a Streamlit application. Well done. I can't get out your names now, so I might not be able to call out your names, but thank you very much. Well done. Great job. Okay, so let me just share the Streamlit Sorry. Let me share the Streamlit. The slide over you. Okay, so we have another quiz. Let's just take this short quiz as we wrap up. It's going to be very, very simple. Let me share the link. Yes, you can submit your application for volunteering. We review application in a rolling basis, so we'd always get in touch. You can submit your application if you're interested in volunteering with us. You're welcome to join us. Thank you. All right, so that I just shared the link. Please let's join quickly. 1 minute. Okay, I want to know how far we've joined. Have we all joined? Let me check. Um okay, because of our time, we do not have so much time, so let's just get started. They are all 20 seconds quiz, and we're gonna start right away. All right, what's the first step to using a Python package? What do you do? 14, 13, 12, 11, 9, 8, 6, 5, 4, 3, 2, 1. Thank you, everyone. We all got the answer. Almost everybody got the answer. Yes, you first of all install it on your system using pip. Good. Thank you, everyone. Okay, so the next question, 2 minutes, 10, 20 seconds. What command do you use to import the whole of NumPy package? The whole of NumPy package. 7, 6, 5, 4, 3, 2, 1, 0. Okay, so let us reveal the answer. Okay, import NumPy. Thank you, everyone. All right, so let's take the next question quickly. To use only a specific function of a NumPy package, for example, array, what is the correct code to import this? Five, four, three, two, 1, 0. All right, we all do. I mean, we all doing very, very great. Thank you from NumPy. That is from the name of the package. Imports the name of the module. From NumPy imports array. All right, thank you, everyone. We did so great. Mandy, Otabil, Joy, Mark, Sasi, Chima, everybody. Sorry, I can't call everybody's name because of our time. Thank you so much for attempting this. I hope you've learned something. And now let us see what we can do. Okay, it's time for our open forum. Is it that we take open forum, or let me just take like 10 minutes out of the time to do Streamlit. What do we think? Oh, sorry, Oluwa Damifola. All right. Okay, so let us go ahead. I think I've gotten a yes, so let me just quickly continue. Yeah, so Streamlit is a very interesting package. In fact, when it came out, it was, I mean, made life so easy. Because before, after building all your machine learning codes and all, and most times when you're working with other developers, I know, or maybe you want to present your application, I mean your solution, people will be wondering how do they actually test it, right? How do you test your solutions? And then you have to create a Flask, use Python Flask, Django to create a simple web application just to show your work. But then Streamlit just came into play and then made life so easy. So I'm going to show you how to use that. So if you have VS Code, so that is where our VS Code will be coming into play. If you have VS Code, um uh you would be using your VS Code. VS Code, Visual Studio Code, is a coding it's an integrated development environment where you can write so many codes. Apart from Python, it supports other languages, but for this class we are using for Python. And I'm going to, let me see how I can do this. I want to show you how to use it. So when you launch your VS Code, after proper installation, you just open the VS Code and then the interface looks like this. First of all, let me just share the Streamlit interface. I think I'm on the right screen. Okay. So when you go to Streamlit dots, I don't know why my system is okay. Let me just, can you still see my screen? Issues. All right. Okay, so Streamlit is a very it's the website is streamlit.io. So when you get to the website, you see different apps that people have built. It's an open source Python framework. Python package. Some persons came together, they developed it, and then you can use it to publish your different Python application. They're amazing, beautiful apps that people have used Streamlit to develop. So to use this, for example, you've developed for example, like you built a simple calculator in Python. You wrote a Python function that can maybe build a calculator. I want other people to use it in class or online. I'm just using that as a use case. So you can use Streamlit to present your work or to showcase your work. So it can be used for several other things. It can be used to even do a mini chatbot if you want to integrate it with ChatGPT. And then maybe we might do that demo in one of our open master classes for the whole community. Can integrate it with your ChatGPT and create your own chatbot with Streamlit. Can integrate it with your ChatGPT API, create your own chatbots where people can interact with it. You can attach it to your blog or attach it to your website or anywhere. Okay, so that is how good this framework is. So there's a mini documentation on the setup, the installations, and or what have you, and the fundamentals, the first steps, and all of that. So we are going to just do some of the we're going to use I'm going to use some of this some of what we can do with Streamlit. I might not be using some packages. I'll just print some of the models so that you can get to know how to use it. Okay, so the first thing to do is to install Streamlit using pip. just like, you know, we know it's a Python package. You have to install it using Pixel. Let me just share my VS Code environment. I hope I won't take all the time explaining this, so that we'll have some time for Q&A. Okay, so this is VS Code Visual Studio. Let me just create a new window. Okay, so when you start Streamlit, when you launch your VS Code, this is the first thing you see. So the first thing you do is to, for example, you must have created a folder in your system where you want to have your application stored. So if you don't have it, if you have that folder, you can just open that folder using open folder. But then, okay, let me just open the folder. Let me create something on my desktop. Let me just create a new folder and say, streams. Let me just create a folder called streams and then select this folder. All right. So it's going to come up, bring up something like this. Yes, you trust. Then now here, this is the folder you created. You cannot create a new file using this plus button, create a new file. You can call the file, and now that's what I'm talking about. Now, if you want to create a Python, a full Python package, you have different things that you need to put together in your directory. But we don't have time to go into all of that. But let me just go into the basic. For example, I want to create just a single Python file. I can just write app.py. It could be any other name. For example, we can see if we want to call the name of our app calculator. So this is just like a module, right? You could have many other files with different Python files, different functions. So you take note that this is not IPython notebook that we've been using before. This is like a Python file now in our VS Code. So VS Code, we can use it with Git. That's if you're able to touch on Git and GitHub during this bootcamp, I'll show you how to do that. But then you can use it with Git. You can use it with, you can just integrate. It's a very, very nice environment. So for example, now that I want to use this, we've created the calculator.py, right? Because we want to do Streamlit, the first thing to do is to what? Install Streamlit. Because if we want to use it before installation, you do import Streamlit. You see that it's already showing you that there is an error, because what's the error? Let's check that. It said remove unused import, remove all unused import. That is, okay, here I've not used it. Let me see, Streamlit. Okay, now let me see the error it's giving me. Ignore support. Okay, normally if this is not installed, that's when it gives me this kind of error. So let me now install it. How do you install it? I can go to my terminal on VS Code, click on you see terminal, click a new terminal. When you click a new terminal is down here. So here you can see that you have different you can have a PowerShell. A PowerShell is the default for an account, like it is the default Windows shell for VS Code. But most times I like using either Git bash, maybe when I want to connect to my GitHub, or I use command prompts so that I can easily navigate. And then now, when you're using, for example, now I'm using my command prompt. I selected the command prompt terminal. I have a new terminal, and this is where I can do my installations and all my pips and all of that. But usually, before I do my installations and pip, there's something I like doing. I like to create a virtual environment. What is a virtual environment? A virtual environment is like you creating a separate environment from all your other installations on your system, because sometimes when you're working on different different applications, they have different requirements. Sometimes some might require Python 3.9, another one might require Python 3.10. So if you are doing all your installations on on the same on the same local directory that is on your C drive, it's going to be conflicting with other applications on your system. So usually you can just create a virtual environment using Python dash, that's Python, that is the name of my virtual environment dash M. And then I'm saying it's a virtual environment, and the name of my environment, you can call this environment any name. Here, I just want to call it .vnv. So when I do this, it creates a virtual environment for me. We notice a new environment has been created. Do you want to select it as your workspace folder? Yes. So now I want to use, my I'm creating the virtual environment. Now take note of my top right hand corner. You can see here that a new environment has been created on my directory. And this is where I can do all my installations for this particular application I'm working on. So I can just do shift. I can activate. The next step is to activate the environment. I want to make it active. So I use the name of the environment .n/scripts./activate.bat. This is for Windows. So there's another way you can use for Mac. It's a different code. There's a different way you activate the Mac. I might not be able to go into that for now because of time. I'm trying to race against time. All right. So after activating your environment, you notice that we are now on our virtual environment .vnv. So now I can now start all my installations. The first thing I want to do is pip install Streamlit. So if your pandas, your numpy is not installed, you can do the installation here. That's if you are using VS Code or any other package. So when you do pip install Streamlit, your installation begin. And I hope that I have a very fast network. While the installation is going on, I can just begin to set up my since I'm creating this is simple, I can create a function called dev calculator. I want the calculator. Let's just create a simple calculator because of the time. I want to calculate two numbers, A plus B, or then you can just say C equals A plus B. Then print or return. I'm just using the simple use case that we've used in class, right? So this is our just put your comments calculator. Function. And then this Streamlit.write is a way of just saying that, just giving it a name, your application a name. You could just say, this is a simple calculator. You could even create a navigation bar, Streamlit dot sidebar. You're telling the user enter dot right. Select your, or maybe enter your number. Enter your numbers. Okay, so let me, my installation is done. So let me check if your Streamlit is working, application is working. You can just do streamlit.run. Streamlit run, then the name of your calculator. You can see that the yellow thing that was underlining is gone because now my Streamlit has been installed. So I can just say Streamlit run calculator.py. So it's showing that my Streamlit is running. Now let me get my application to work properly. Let me save it and refresh the Streamlit page. You can see all what I've written is coming up nicely. So now I want the user to, I created a sidebar where the user can enter a number, their numbers. So I'm going to just put Streamlit sidebar. But I can use let's use a text bot. Is it a text bot? What box can you use to collect a number? Is it text input? Okay, let's do text input. Enter num1, first number. Now, you see, as you're writing, that's the good thing about VS Code. It's telling you the label and then the value, right? What you want the Streamlit to write. So you have the label and then the value of the Streamlit application. You want it to be there's a value. I'm going to leave the value open. So let me just let me store the value somewhere. Let me call it comment. Let's just run it and see. Name Streamlit is not defined. What is happening? Name, which Streamlit is not defined? Now you can even use a short you can use a short alias. There's something called alias, right? Now you see that I have my number now. By default, I've already said they should enter num1. So I've given it a value. I should be faster. Let me just give it a default value 0, right? And then, so I'm going to convert this to ints because whatever the user enter, the user might give me, and it's going to be a string. So let me just convert any value coming into an integer. So you see the beauty of, as you're writing, whatever you're writing, it's coming out, you're seeing what you're writing. So why is this giving me an error? A plus B, int A, int B. Okay, let me use the integer here. All right, so now enter your first number, enter the second number. Oh, our time is fast spent. Second number. So let me just supply let me use the number. Let me give it a variable name. Let me say num1. 1 equals. I don't know if we understand what I'm doing, but it's similar to all what we've been doing, putting everything together, num1 and num2. So I'm just assigning to a variable. Now I've already I'm collecting input from the user, right? Now I want to apply this function that I've defined here. So I'm going to say, how do I reuse our function here? So when we reuse our function, we're going to call calculator because I want to display the result to the user. Calculator. That's the name of our function. And now the user is going to supply me num1 and num2. So I'm going to say num1, comma, num2. That is the name of, that is what the user is going to supply me. So for this calculator to get printed out, I have to supply it to the user, right? I'll just say Streamlit. By the way, you can use alias because of our time. That's why I'm just using write the result. I want to write out the result now. Let me just write out the result. Thank you. Let me just write something. Your answer is let me store this calculator inside another variable so that you can just say answer. Your answer is answer. All right, so this should run. Let me run it. So what I just did here, I imported Streamlit. Let me run it now to show you the output. So when we run this simple application, now the user enters the first answer, number 5, enter the second number 7, and then there should be it has automatically calculated the answer, but I wanted to press there should be a button to submit, right? When I click the button, and then you can see that it has given me my answer automatically. 5, 7. I don't have time to implement the submit button, but it's just that show you the flexibility of what Streamlit can do. So this Streamlit, you can use it to build a dashboard. So our project, I will be sharing with you what the project will be all about, whether you're going to be using, for I don't know if you can see the output page. Let me share the output page. I could not navigate around the 2 pages. Let me share the output page the way it looks like. Now, this is how the output page looks like. You can see that the first number is, you can say 79. The second number is what? 790. And when you see that it's giving you your answer already. So I could have put a button here, just had some other flexibility. Then if I want you to use it, I'm going to deploy it, attach it to, when you click deploy, you can either deploy on a Streamlit cloud, or you deploy on, use a custom deployment for companies. You can deploy it on your own, your Docker or your cloud. So if you want to deploy on Streamlit, you can deploy it. You connect to your GitHub profile, deploy it, and share the link with everybody to use. So I'm going to stop here. I don't want to take our time further, but I hope you get the basic of what we've been discussing, so far. It's been very, very, it's been a great time spent together, and I believe that you've learned one or two things. Because of our time, let me just take 1 or 2 questions. The other question will just, I would answer it via chat, just answer it on the group, and then would because of our time. So do we necessarily need to create a virtual environment before installing Streamlit? It's not compulsory, but it's advisable because of, I explained earlier, because of conflicting installations. There are sometimes that I've worked on some applications, and because I didn't create a virtual environment, I've had to reinstall my whole entire environment, my Python environment again, because one application was conflicting with the other. But when you create a virtual environment, you create a separate, like keeping your code in a separate bag. Let me just use that layman explanation. And then it's easy for you to work with your code. If when you are done, you can delete that environment, and then it doesn't interfere with your original setup. All right. So this okay, I think I've answered. The global variables are effective outside of the function. Okay, somebody was asking global and local variable. Okay, about global and local variable. Thank you, Luadami Fola. I hope you get to understand the difference now. All right, I think those are the questions I can see for now. If there are any other ones, we can address that in other classes. Do we have any other questions before we? Okay, the course materials. Like I told us during the last class, if you check the recording, I had already demoed how to get to the course materials. You should have had access to the LMS if you're in this program. Please, we noticed that so many people are not yet on the LMS and so many people are not attending class. It's part of the requirements for this program. Please tell your friends if they were part of this cohort, they're part of this cohort to ensure they get on the LMS and also attend classes. All right, so let me just go to the page, this page. Okay, so the classroom, we have in the classroom, you have, this is the bootcamp page, classroom page. Trying to get there. Sorry. Okay. So when you get to the website and you have access to the LMS, you can just go log in, navigate to my programs. When you navigate to my programs, right? You're on the LMS, you can go to your programs. If you have been accepted to the program, you see your program, click on view program, and then you are inside the LMS. When you get to the LMS, the course materials for each of the content or what we discussed, right? It's here. For example, you have introduction to data science. You can see all of these. This is the IPython notebook. Most of them are attached towards the end of all the stories, the video and text explanations. So you see them under each of those modules. You see each of them, like the dictionaries, the set, and the tuples. This is the dictionary. This is the course material for dictionaries. So I hope you get that. Then for the recordings, you can find them under this here. You can find the recordings here as well. All right. So if there are no other questions, do you have any other questions? Are you talking about the link to the LMS? The link to the LMS is just the website. Just go to the website, log in. If you have been accepted to the program, the program will be displayed on your dashboard. But if not, you have to request to join there's a mail that was sent to you. If you didn't get that mail, you can send us a mail again. I will resend it to you. Check if you are in the if you are supposed to be in this training, and then we'll send the link to the MS to you. Regarding the exercise, what is the process of importing them into the Jupyter notebook to solve the question? Okay, importing. Was there anything that we had to import into the Jupyter notebook? Okay, let me show you. Okay, Olayemi, yes, we're in the process. We are working on some modalities, and we'll get in touch with you soon. So expect us to get in touch with you. All right. So concerning the model, the exercise, let me just show you an example of one of the exercises so that you would understand what you're supposed to do for the exercise. All right, so this is one of the exercise. Let me check if I have it here. Sorry. Okay, so now this is one of the exercises that we have to submit. Now, after you download it, right? When you download the exercise from the LMS, you save it inside a particular folder. Now here, I've saved it inside this folder called Python exercise, right? So you have to launch your Anaconda. You launch your Anaconda, your Jupyter notebook, like if you don't know how to launch, I think the video for the first class, I took us through the process of how to open and launch our Jupyter notebook. So after having launched it, you go to the after you launch your notebook, you should have this browser, this interface. Then you can now click on this exercise. Having clicked on the exercise, you see this particular question. The first question says, what is 7 to the power of 4? So what you're just to do is to let me just do the first one. You are just supposed to write an expression. This is the answer. So don't load this cell because this is the answer. This is what you're supposed to get. So you can just say, maybe create a variable called a equals 7 raised to power, because that is the power function, to the power of 4, and then print a, and you can see that this is just what this is the solution to this. So once you do this and then you get the right answer, you're good. It's most of the exercises, this is the answer. This is what we're expected to see. So you have to work out your solution to get to this answer. So and we want everyone to submit so that we won't see our thought pattern. So this one is an indexing format. You have a nested list. We want you to grab the word hello. So how do you grab the word hello? With what we've been taught in class, we should be able to grab this hello. And this is the output. So that's the first exercise. The second exercise is also there too. Second exercise is there. Yeah, as well. Create a function and all of that. The final problem. You could solve this, create this final problem and even publish it on Streamlit as well. This is like you have to write some control flow statements here for this final problem. All right, we've taken so much of our time. Sincere apologies. This is 13 minutes. The link for the exercises will be under the class recording. There'll be we're going to put a Google form where you can upload for each of the exercises, and you send us a link, you upload your notebook to the Google Sheets, and then we'll get to review your exercises. All right. Thank you all. If there are no other questions, I hope you all have a nice and beautiful weekend. So it's a weekend. We have a long weekend. So try to do catch-ups and all the readings, the recording. And if there are any questions, you can always reach out. We'll be available to support you. Enjoy the rest of your evening or morning. Thank you, everybody. Thank you, our volunteers. Thank you. All right. Thank you, Madam Ify. Thank you. We are closed already, but let me just you wanted to say something, Olatunde? I unmuted you. You can talk. You want to say something? Okay.
Yes, can you hear me?
Yes, I can.
Oh, very well. Thank you very much for today's class. It was quite insightful. Thank you so much.
You're
Please,
welcome.
yesterday I sent an email. I sent it was actually a request. I'm hoping to get a response as soon as
Okay.
possible, please. Yeah,
Okay.
yeah. I'm actually new to the tech space, and I'm
Okay.
finding I'm struggling to catch up with the whole technicalities. So I was
Okay.
hoping to switch to data analysis with Power BI with introduction to machine learning.
Okay.
Yeah, instead of
Okay.
this, so I could just learn the basics and grow from there to data
Okay.
science.
Okay. Okay. Yeah, it's possible for you to do Power BI, but if you want to do machine learning, you have to know Python. So machine learning is even more advanced than this. Like you'll be doing so many. But if you just want to start up with data analysis, you could just
Yes.
start with Power BI. The Power BI is more you still need some data analytical skills, but it's more like into visualization. You see, you are doing data storytelling, you're
Yeah.
doing some, you'll still be doing analysis, but then it's more like interactive.
Yeah.
And yes, so but then if you want to change your model, the course rather, it's a
Yes.
welcome. It's welcome. Okay. We'll check out the mail and will you get a response?
Oh, thank you so much.
All right. Thank you too. Henry, you want to say something? I unmuted you. Hi, Henry. Do you want to say something? Okay. All right then. If we don't have any other comments, let's have a wonderful